Thank you very much. Good morning, everybody. I very much appreciate your presence today after the long party yesterday. So I hope you enjoy what I'm gonna talk about today. I'm gonna jump up and down, so I don't know. I hope you can hear me. So I think it's obvious for everybody in this room that seabirds are special. Yes or no? Of course. Of course they are. We are all impressed by seabirds, and we are impressed for different reasons. They are magnificent flyers exploring vast oceans, and when we look at them, we ask the questions, where do they go, and where they go, and then why do they go where they go, and then we ask also the question, how do they know where to go, right? Then we are very much impressed how efficient foragers there are. And when we look at them, we ask the questions, how do they locate their food? And why this food and not the other? And then understanding how sensitive seabirds are and how essential for the functioning of in this ecosystem, we consider them as sentinels of the ongoing climate and anthropogenic changes. And some of you may say seabirds got the cutest baby birds in the world, and that may be the question of the taste, but there is something in it, especially if you start to compare. But most importantly, and this is what I would like to focus on, seabirds are truly devoted parents. But parental care in seabirds, it's not that often investigated. I wouldn't say it's entirely neglected topic, because there are studies, but compared to other research areas, they are kind of, they are not hot topic. If you type in a Google Scholar seabirds and ecosystem, foraging, climate change, migration, contaminants, wintering, and parental care, these are results for the last 24 years. So it's not like nothing, but still not that hot topic. But most importantly, when you look at the taxonomical representation in the area of research on parental care in birds in general, seabirds are only like few % of the whole studies. And it's a pity, because seabirds, we can learn a lot from them. They offer very unique perspectives. And I'm gonna elaborate on that, but before this, let's pause for a while and consider why there are not so much interest in parental care in seabirds. And to do so, Zawodowski Island, that was the name. We could see yesterday the videos, right? You are the audience who well understands how challenging it is to study whatever in seabirds. They usually breed in remote, isolated islands or like places like Zawodowski Island, and where the conditions, weather conditions are, euphemistically speaking, not favorable. And one needs to be very fit and super enthusiastic to collect the data. But more importantly, if you want to establish like a feeding rate, which I would say is a basic parameter when it comes to the parental care, you need to consider time window, pretty long time window, to cover a reasonable number of feedings. Like if we compare it with passerines, to be fair, let's consider a blackbird, so medium-sized insectivorous passerines. The parent, each parent visits a nest 1, maybe 3 times per hour, right? But the little auk, roughly the same size, also zooplanktivorous bird, it comes to the nest the same number of times, but per day. So to establish feeding rate in the little auk, one needs an observation that would record, like for the blackbird, one needs an observation which will last 1 to 3 hours the most, and for the little auk, it will be like good practice, and reality is like 3 days. And obviously, nowadays we've got devices we can deploy on birds, and they will measure things for us. And they are wonderful, but they don't work that straightforward, that we know also. They've got also their constraints, but once they work, we can get a lot of data, and they may be quite accurate. And here I will use this opportunity to show you that you can use geolocators to study parental care in seabirds. That was the study, one of the chapters of PhD of Antoine Grissot. He compared the usage, he compared geolocators data with video data. And he found that actually using a combination of conductivity and light data, which are like default geolocators parameters, which we use for consider migration and wintering, they are also very useful when you look at the birds' foraging and colony attendance. Because when the loggers are wet, birds are foraging. When they are dry, they are either in the colony or in the nest, and then you distinguish between the two given considering the light data. So it works for the little auk, which is crevice nesting bird, and then yeah, it comes with a great help. So. Devices and biologging are great. They've got their constraints, but yeah, they are great, but sometimes they cannot really replace observations. And also observations on their own, when you look at your birds, when you look what you are studying, you may better understand what you are actually studying. So that's one point. And the other thing is, like, when you look at your birds, you can sometimes discover things which you don't really look for, but they are super interesting. And then when you look at the things with an open mind, you can spot them, and then you can discover, like here, Annette Fayette with colleagues, they described tool usage by puffins. Or Martina Sepos from my lab, she spotted like alloparental feeding in the little auk. So these are observations. These are just reports, and but they are important because they can be inspirational, and accumulating with time, they can actually. They may help us to understand the different issues. So observations are important, and here videos recording comes with a great help, and one can set up the camera and record whatever, and the camera doesn't get tired. I mean, it needs energy you need to supply, but as long as you supply the energy, then you can record the things with great details. And then the thing is, like, the only problem with the video recording is, like, at some point, someone has to process these videos, and it takes ages. If you consider, like, a very simple, study, where you, let's say, need to consider, like, 20 nests, and then for these 20 nests you set up 20 cameras, and let's say you want to look at the birds at different stages of the breeding. If it's a chick rearing, it will be early, mid, and late chick rearing breeding. So this will make 3 sessions, and if this is the little auk, the duration of the sessions will be like 3 days, so 72 hours. In total we have over 4,000 hours, which is half a year, and to process. And one needs to eat, needs to sleep, and needs to do other stuff. So one way to overcome this, to handle this amount of material is, like, to set up your video in a time-lapse mode. So if you do so with to record 1 frame per second, yeah, you will save a lot of time. Like, it greatly reduces the amount of video material. But and this is what we are doing for, in the Little Oak. But there is apparently still room for improvement, because when you look at such a video recording, there is a lot of empty time intervals which you could skip. And now I can sense this suggestion you have in mind, camera traps, right? It comes with a help. But for the Little Oak and some other systems, I guess, it doesn't work. The camera doesn't, it's not triggered when with a very short visits of the parents, which happen pretty often in the Little Oak. So we've got these empty spaces, in time intervals, and we want to skip that. And for that, we created Behave. And that's a little commercial right now. Claude Elhorst, who's an IT specialist and a friend of our lab, he created the whole framework which serves to process videos, not only continuous videos, as I'm showing you right now, but also camera traps videos. But the most important issue of this framework is it can detect, using the artificial intelligence, it can detect the frames with the animals on. So this way you can skip the empty intervals, saving a lot of time. And the other thing is you can process this application also, this framework also contains a watching video mode where you can create your ethogram, and then you can watch your video and code the behavior. So in this, working within this framework, you can save a lot of time, and you get data which are very consistent and well organized. So I really recommend you to use this app when you've got your videos. This is already done, not yet published. We just submitted the manuscript, but the website, which is still being developed, but already available, is on under this QR code. And if you've got any questions, you can write us an email. Here is Claude's email. So studies on parental care are challenging. Parental care in seabirds, they are challenging, but they are doable. And now I would like to focus on why they are so important. So the story starts with parental care being costly. And the parental care is like always beneficial for the offspring, but always somehow costly for the parents. And the more effort they put in, the more costly it will be. And these costs, they generate different kind of conflicts. And if you've got two parents caring, they are likely to fight over who and how much they should contribute into parental care. And then for simplicity and being blind for anything else, like just given basic sex differences in reproductive potential, males will benefit from mating with multiple females, and that's in conflict with parental care, while females, they won't benefit that much with multiple mating, but they can increase their fitness by caring for the offspring. So if parental care is needed, then considering only this basic sex differences in reproductive potential, then females are kind of predisposed to provide care, and in this context, the male care is optional. And birds are quite unique because, as it comes to parental care, because most species exhibit parental care, biparental care, but when you look at the male contribution, it really looks like optional. Here are two phylogenetic trees which indicate amount of parental care system during the incubation and during the chick rearing, and the amount of red color indicates biparental care. The amount of the yellow color indicates uniparental care, namely female care in most of the cases. And you can see that During the chick rearing, indeed, it's very reddish, so there is great male contribution, it's biparental care, but during the incubation, it's very yellowish, indicating it's more like female care. So male here is kind of optional. And in this context, this biparental care is an effect of interplay between male and female. They are believed to constantly negotiate and monitor themselves like while providing this care. And here is very simple model, pretty old one, but simple, so good to actually illustrate the point. We've got in this model a fixed amount of male and here I need to do fixed amount of male and female effort, and they are supposed to provide this amount of effort. If not, the system will erode. So if a male would decrease the number of feeding for any reasons, and then females would like to compensate that, that will provoke the male to decrease the number of feeding even more, and then she will not get male help anymore. So they are, the male and female parents, they are supposed to hang around this point as it comes to the amount of parental effort. And when we look at the passerines, it looks really like that. When it comes to the amount of parental care, they seem to monitor themselves and negotiate it. And there was a very nice study of Johnson and colleagues on the great chicks. They show both theoretically and empirically that the partner, they speed up the feeding rate after its partner visited the nest. Then they are like alternating the feeding and they nest visits and they monitor themselves. But it will slow down the speed rate once it visited the nest in turn. So this is kind of waiting for the partner to do their job. Otherwise, it will not work. So this is the picture which we can see when looking on passerines, which are like model species when it comes to the parental care. And then there we've got seabirds, and when you look at male and female performance, they are surprisingly agreeing on parental care. They are truly devoted and cooperating, and they have to be like that to be successful. So what I'm now gonna show you is related to the little auk, but it's actually true for many species. If we generalize a little bit, it will be actually true for all of the seabird species. So the first thing is like the brood size is very restricted. In the little auk, the maximum, like a single chick, they raise a single chick in a brood, and it's believed that this is because of the natural environment, which is pretty harsh. The birds, they forage in a sea, so they make a long distance and distant trips, and to satiate the chicks' needs, they can have only one. So, and there was an experiment with a pretty smart chicks rotation performed by my Polish colleagues back in the 90s, where parents feed. There was always a single chick in a nest, but parents, they were feeding in a 1 or 1.5 or 2 chicks in the nest. And you can see when the chick is just a single chick in the nest, it grows like this, but when there are more bigs to feed, the chick growth rate is not that beautiful. And here is the optimal, energy-wise optimal level of fledgling body mass. You can see that only those which are raised in this natural conditions, they are fine. Others, they are unfed actually. So there is one chick, and then 2 parents are needed for the good chick development. If one parent is missing, the breeding success is like unlikely. So to be sure how essential is the contribution of two parents, one needs an experiment with a partner removal, which is hard to imagine ethically and logistically. But putting something like some kind of burden on birds may create this kind of experiment. And Christine Piening is now doing her PhD on foraging ecology of the little auk. She compares sex differences, and to get this information, we put this valuable information, we put loggers on birds. And then, we get the tracks. Sometimes they are nice, sometimes they are not that nice. And then the birds, they seem fine. They do not really abandon the chick, but when you look at the number of feedings they perform compared to the partners or compared to the control birds, as you can see here are GPS birds and here are partners and here is controls, the number of feedings is much lower, which means GPS is kind of burden. And then decreasing the number of feedings just temporarily and just a little, we can see it's already have an effect on the chick growth rate. Again, it's not like fatal, they still can make it, but then the body mass is not that high. Maybe fledgling body mass is okay, but while the development is not that, it's like disturbed at some point, we can imagine it may have consequences later in their life. So one chick, two parents, and then when you look at the male and female contribution into particular activities of parental care, it's even boring. When I was doing my PhD and I looked at sex differences in parental care at different stages, I was desperately looking for the sex differences. I couldn't see any because they incubate pretty much at the same level, and they perform their feedings at the same level, and only at the end of the chick rearing maybe there are some sex differences but they in the feeding rate, but this is associated with the earlier female brood colony departure, and this is very different story. For most of the season, both parents contribute and they do basically the same things. So with this little oak example, I think we can conclude that seabirds are really special. They've got quite specific set of life history traits. And to that, what I've already said about the brood size and biparental care, we can add lifespan, pair-bond duration, sexual promiscuity. Compared to passerines, for example, these traits are contrastingly different, and as such, they really offer distinct perspective to look to parental care. So let me now quickly introduce you to a framework which I suggested for interpreting biparental care in birds, this framework, I think, highlights how seabird parents are so special. So in this framework, we've got male and female effort on this axis, and then we've got parental capacity, which is denoted by this gray area. This parental capacity has like two zones, like there is an optimal parental capacity and suboptimal parental capacity. And as you can see, there is also like the cost of parental care, which are denoted with this black solid line. And this cost, they are some when the parent operates within this optimal parental capacity, but then they increase when they enter this suboptimal zone. And now let's look at the two systems, like passerines and seabirds. So in these two systems, in both cases, to raise the offspring, parents need to put some effort, and the amount of this effort depends on the environmental conditions. So these red lines here represent the worst case scenario where the conditions are really harsh, and when the conditions are great, favorable, then this is the line for the parental effort required to raise the offspring. And the main difference between the two is the distance between these two lines, which we can call like evolutionary tolerance. And you can see the seabirds, they've got it much narrower compared to passerines. So they are usually operating at the edge of this maximal parental capacity. And then when we, for example, consider such a scenario, we've got a female, if she's on her own, even if she puts them, like for seabird female, if she operates on her own, so here is her maximal parental effort she can put, she cannot really raise the brood successfully because this is the value required. She needs a male contribution, and when it fully contributes, it actually moves female to the zone of optimal parental capacity. Then when you look at passerines, situation is very different because in a good environmental scenario, she will be able to raise the brood successfully. But of course, she will benefit if the male contribute because then she'll decrease the cost of parental care. So the most important message out of this framework is that seabirds are really different compared to other species we used to look at when studying parental care, and we don't really have to look at the parental care in birds as a field of battle between the parents, but as a setup for a close coordination. I need that. So seabird parents, they have to cooperate because this is the most profitable strategy. Sometimes, well, in most of the cases, it's like the only strategy to raise the brood successfully. And slowly growing number of studies shows that seabirds not only cooperate, but they also coordinate their parental performance to get better chick development. And here you've got some species for which this parental coordination has been somehow investigated. And as you can imagine, I will now focus on the little oak. So parental coordination in the little oak, that was the core issue of Antoine's PhD project, and he was looking at the patterns of coordination over the breeding season. And during the incubation, he established that it is about the continuous process of egg warming. So during the incubation, the parents, they coordinate their performance if they match the opposite activities to each other. So when one parent incubates, the other forages. And at the beginning, as you can see on this plot, they are not that good. It's not that straightforward. There is a lot to improve, but over the season, they actually achieve a very, very good coordination. So this is during the incubation. When chick hatches, the situation changes, and this is because chick primarily has to be fed, and that requires parents to perform their foraging trips. And so before we go any further, I need to explain you this foraging strategy in the little oak. So it's important to say that little oaks, they perform dual foraging strategy as procellariformes do. And they are so this the dual foraging strategy is like long trips being alternated with a series of short trips. And long and short trips, they are long and short both in terms of time and space, and time here is the crucial, because short trips, they last from 2 to 8 hours. The 8 hours here is a threshold, and then long trips from 8 hours up to 40 hours. And Darek Jakubas from my lab, and privately my husband, he showed that this dual foraging strategy is only performed during the chick rearing. So it probably serves something which is happening during the chick rearing. And because birds immediately switch from this from different mode after hatching, you can see here such an example of the duration of the consecutive foraging trips during the incubation, which is here, and then later during the chick rearing. And you can see during the incubation, the chicks are really, really long, especially at the end, because the parents, they are very well coordinated and they perform long incubation bouts, so long foraging trips. But then when chick hatches, there is not that much, there is no such a luxury anymore for the parents, and they will perform long trips being alternated with short trips. And it's important that it's independent, this strategy is independent on the foraging conditions. So regardless of the trophic situation in the foraging areas, they will perform this strategy. So it is important. Jörg Welker, some time ago, he compared this foraging strategy at different colonies, like here you can see. And then he found, yes, this is the case in all the colonies, while these colonies, they differ in foraging conditions. And most importantly, the same group, research group, they compare the body mass of adults after short and long trips, and they found that during the short trips, the parents, they lose their body mass and gain it only during the long trips. So it seems like this strategy is to secure adults' body mass when they are provisioning their chicks. So this strategy, this dual foraging strategy, primarily serves to adults. Because when you look at this strategy from the chick perspective, it's very different. It very much depends on the parents' performance, like mutual performance. Because in the worst case scenario, if parents would like to control themselves, and or like if they would perform their trips independently, or they would like to control themselves, so they would do the things together to watch, to monitor themselves, then the chick will be waiting for a very long time for the food during the long trip of the parents. And then it will get a lot during the series of short trips. Such scenario is pretty unlikely to promote chick development. So we expect something different, like the best case scenario where the parents do exactly opposite patterns. So when one performs short trips, the other performs long ones, and then they change. And because this is what we would expect to promote good and quick chick development. So looking at the issue this way, we found that indeed parents do coordinate, little parents, they coordinate their trips in a way that is close to this the best case scenario. This coordination is not perfect. It's like at the level of 20–30%. But if you randomize if you randomize what you observe, like if you randomize the foraging trips of observed duration, and then you calculate the overlap to create a distribution, like random distribution, then the observed value like 20–30% of overlap is different from that what you could expect by chance. And then you can see that this coordination, the level of this coordination, it's negatively related to the variation in time among in the time intervals where chicks is waiting for the food. So with such better coordination of the parents, chick will get food in a more equal intervals. So noticing coordinated performance has opened fascinating research avenue. And once we know that parents, they do coordinate their feeding, we want to know the mechanisms behind. And this chapter is just opening, so there is a lot to do. I will now, for the very end of this talk, show you just a couple of results we have so far in respect to this mechanism, but this is just scratching the surface, but I think it may be inspirational. So first thing is the variation we can observe. When we look at coordination index, whatever stage, we can see there is a lot of variability between the pairs. There will be pairs which perform very well, like this, and there will be pairs which perform not that well. And this is interesting, intriguing on its own, because this variability, as Sam was saying us on Tuesday morning, it's meaningful on its own. Behind this variability, there is something which we actually should carefully look at. And what's interesting here is if we look at the same pairs in consecutive seasons, we can see the pairs are kind of consistent in the level of the performance. I mean, the repeatability you calculate, it's not super impressive, but it's different from zero. So these are like kind of preliminary results, but they naturally generates the question about the reasons for such a variability, and I think it's worth to consider. So to a little bit tackle that question, we started to look at pair bond duration in the little oak, distinguishing newly formed pairs, so with partners breeding together for the first time ever, and old ones where the partners were together for at least one season. And this data on pair bond duration in the little oak, they are really hard to get. So this is why there are so little dots. But you can clearly see there is a pattern, like newly formed partners, newly formed pairs, they are doing a little bit worse. So it probably needs some time to get partners to synchronize, to coordinate their performance. So as it comes to the mechanism, Tash, Gilly, and colleagues, they recently considered body condition as a mechanism behind the coordination. They found that the time monkey water parents stay on the nest depends on the body mass, and the higher the body mass is at the beginning of the incubation bout, the longer the parent will stay in the nest. So this is very, very valuable information about the potential mechanism of the coordination, which I was showing you. And but then there is also the question of how parents examine their body condition and then adjust their behavior. One possibility is they communicate their body state and maybe even readiness to stay in the nest. And many birds are pretty vociferous, and the little oak is not an exception. These vocalizations are likely to be important for their communications, right? Including partners' interactions. And Ania Osiecka, who just finished her PhD on little oak vocalization, she found that vocalization in the little oak is very much context dependent. Depending on the situation, they will broadcast different vocalization, different type of vocalization. And then she also found there is a relationship between the body size and the acoustic parameters of the vocalization, whatever vocalization we consider. So there is a potential in the bird's vocalization and as a mechanism, direct mechanism of the coordination. And Marion de Vogel from my lab, she actually considered that, looking at the vocalization from a little bit different perspective, because she didn't really consider, analyze the bioacoustic features, but just the duration of the vocalization. And she found that the more parents vocalize during the meeting while they are changing at the nest, the longer will be the incubation bout just after. So maybe this way they communicate how ready they are to stay in the nest, and based on that they adjust their behavior. Oh, I forgot. That's important. They are vociferous. And while staying together, they are interacting a lot. We just not yet understand what they are talking about. So these results, they may raise a lot of questions. They, for sure, they leave you unsatisfied with the issue, like you want to need more. But yeah, I'm showing you to encourage you to do more research because we need them a lot. So with this slide, I would like to thank you, many people from my group for the hard work and enthusiasm for the questions on parental behavior, and thank you for your attention.
Thank you, Kasia, for your wonderful presentation. So we have time for questions now.
Thank you for this talk. Do you have any clues on the different pairs coordinating differently at different... So you had different pairs with different levels of coordination. Do you have evidence for difference in fitness? Or?
Evidence of the fitness of the
yes, like
fitness consequences
yes.
of the coordination?
Yeah.
Yes, I expected this question. No? Yes and no. The thing is, like, we looked at the coordination and the chick growth rate, chick body mass, differently measured, and then we couldn't see any link. But the problem is, like, the little oak has just a single chick, and yeah, you know, there is a lot of failure needed to parents. If there are two caring, it must be really, really bad. They fail. So the chick, they will grow, it will develop, even sometimes it will be in a better, sometimes in worse condition, but yeah, they will be successful. So our hypothesis, which I'm afraid we never be able to verify, is like it may have long-term consequences. Like if you are a chick of bad parents, then later in your life you may have a trouble to survive, to adjust to the changing environment. This is like the silver spoon effect or earthy phenotype hypothesis behind. But for the seabirds, it's really, including little oak, it's really hard to tackle this question, because for that you need, you know, to follow the chicks in the adulthood, which is really hard to do, at least in the little oak.
Yeah, thank you for a great talk. It was super interesting. I was really interested to see how well conserved these patterns of long and short foraging trips were throughout the season. I really thought it would be a function of foraging success for those adults. So is there somehow a constraint here, or is it just really, really great foraging? Because otherwise there's the negative energy balance, the investment from the parental side.
Yeah, that's a good point. The thing is, like, we looked at the coordination in different foraging conditions, and we couldn't see clear patterns, maybe because we were looking at the mean, not at the variance. This is something which we want to explore in the future. But it's depends on the parameters you are using. So in one of the contexts, we were considering that if I remember correctly, it seemed like if the conditions are good, which could be expressed by the high energy value of the food the chicks, the parents bring to the chick in given season, the coordination is higher. So it seems like they're actually coordinating well when the situation is good, but not that well when the situation is bad, which is kind of counterintuitive. But yeah, apparently they want to coordinate, but sometimes they may not able to do because of the environmental constraints.
Thank you.
Yeah.
Yeah, thanks very much. So you had the sort of visualization of like what would be the ideal level of coordination from a chick's perspective, but clearly that may not be the same as the ideal amount of effort put in from an individual like parent's perspective in terms of like balancing, investing in their chick, not overburdening their partner, and looking after themselves in the long term. So have you been able to like think about what an individual's ideal long-term, lifelong sort of strategy would be, and see how close they are to kind of that kind of optimization perspective?
That's a good point, but yeah, we haven't really quantified that directly. We just assume that with this dual foraging strategy, I was explaining you how it works, this parents' interests are somehow secured. So actually, this coordination may be even more important, not that much for the chicks, but for the adults, like to keep them in this optimal parental capacity zone. If they are performing in a good way, then the chick is secured, but the most importantly, they can go to forage for their own needs when they need.
I have really nice talk. It's not something I know a lot about, so apologies if this is a stupid question, but it's kind of about the natural history of, is it right that little auks, the male carries on caring for the chick once it's fledged?
Yes.
So how does that play into this? Like, is there some sort of, do you know anything about that, the kind of cooperation towards as fledgling arrives?
Yeah.
Like, how does the female anticipate whether the male is going to be a good parent? Do you know anything about that?
So this female brood desertion, let's say, it has been a research avenue for a long time. Like, we are still doing research on that, asking why this is the female who like deserts, why this is the male who stays. It's indeed happening. And then, but we haven't yet looked at the coordination and female brood desertion, but we found that females are kind of flexible in terms of the timing of the brood desertion. It's like the overall and simplified conclusion of that what we've done so far is like if the parental care is not needed anymore, they simply stop feeding and they depart. But if they are still needed, they will stay until the very, very end. So like now with this changing conditions, we can see more females staying at the very end, while like 20 years ago, when we started to look at the issue actually, females were leaving a week before. And yeah, what is happening just before, we don't know, but we also believe like this parental coordination actually helps female to depart earlier, which may be beneficial for her, like in terms of survival, like wintering survival.
Okay, thank you. I'm thinking that sometimes the two birds have to be in the nest just to confirm the pair bond. If there is too much coordination, they will never meet.
That's true. That's true. Maybe this is why they don't coordinate that perfectly. That's true. That's true. That's true. That's true. Yeah, but the thing is, like, it cannot be perfect because yes, yeah. If they stay together, that would be perfect. But the best case scenario, it will never be true because the foraging trips, they differ in terms of the duration. They are not like fixed. So yeah, that's true. But actually, this partners encounter, this importance of partner encounters, we are now actually looking at. So yeah, now I cannot really tell you how it looks like in the little, but maybe in the future we'll be able to give you the answer.
Thanks for the nice talk. I was wondering if you have any idea if the chick condition itself is influencing the parental investment in short or long trips, like the bagging intensity of the chicks, or if they have the feeling or they know the chick is doing well, maybe they invest more in their own body condition.
Yeah, that's a good question, and I mean, I could elaborate for an hour. Again, we haven't tackled directly that question, but we look at the parents' performance in respect to the chick bagging behavior. And of course, parents, they do respond to chick bagging, like they increase the number of feedings, like if the chick bags more. So yeah, that naturally can affect the coordination, and then there is a question how like respond male and female to this chick needs. We found like there is no sex differences in the response so far, but what is like interaction? How looks the interaction when you look at the interaction between the partners? We don't know yet.
Really interesting talks, thank you. I was wondering if alloparental care can affect the coordination of the pairs. So you were saying that you did this study about the alloparental care, but were you able to kind of assess the coordination within the pair, like the nest that has been seen with the alloparental care? I don't know if the question is...
Yeah. You are asking about the coordination in this nest with alloparental care.
Yes, exactly.
No, we haven't looked at the coordination. We look at the number of feedings performed in this nest, in this particular nest, and it was like we found this alloparental feeding in two nests, and in one of the nests, the nest was just normal, like within like in the middle of the distribution for the population. And the other was like a little bit unfed, but yeah, we didn't really look at the coordination of the partners. That's a good point. Good point. But then we need probably more of these cases to get something valuable out of it.
Any more questions? Okay. Thank you again.
Thank you.
So now we'll move on, and we'll be welcoming Bertille Mohring from the University of Liverpool, which will talk about costs of reproduction in black-brown albatrosses.
Yeah. Down if you want. Yeah.
Okay.
What you prefer?
Okay, maybe here.
Okay.
Yeah. Thank you. Hello, everybody. My name is Bertille Mohring. I'm a postdoc at the University of Liverpool, and I'm going to talk to you today about aging, and especially reproductive aging in albatrosses. So to begin with, I won't teach you anything. Variation in breeding performance with age has been demonstrated in many species. To briefly summarize it, you expect breeding performance to increase in early life as individuals progressively gain experience. You expect then it to stabilize or peak at an intermediate age, and then to decrease in late life. And this decline in breeding performance with increasing age is often referred to as reproductive senescence. It is thought to be driven by several mechanisms, including a physiological decrease in fertility, but also a decrease in parents' ability to provide for offspring. And indeed, reproduction is costly, and that's because within an organism, resources are often limited. Parents, therefore, have to decide on how much energy and resources they allocate to self-maintenance or to offspring production and care. And how much you will invest in the current breeding events depend on many things, including an individual's phenotype or interesting state, environmental conditions, the quality, the quantity of resources available in the environment, but also on potentially on carryover effect of past reproduction, with the idea that individuals may accumulate cost of reproduction during their life and pay it later in life, mirrored in reproductive senescence. And interestingly, we can see that the traits that are associated with investment in reproduction or survival often vary. And the pace of life framework has been proposed as some kind of framework to explain this covariance. On the one end of the spectrum, you can find species, populations, or individuals that have a faster pace of life. They're characterized by an increased allocation to current reproduction at the cost of survival and future reproduction. They often start breeding at an earlier age, display higher reproductive rates, and overall invest more over a shorter period of time, leading to earlier and stronger senescence, as well as to a shorter lifespan. On the other end, you find slower pace of lives. They correlate with an increased allocation to current survival and a reproductive effort that is more evenly distributed over a longer lifetime. This is expected to lead to a later onset of senescence and lower senescence rates. But interestingly, despite ample theoretical evidence, there's little empirical evidence supporting pace of lives, especially when we start looking at the individual level. Recent studies suggest that environmental conditions may shape these strategies. But when we start looking at reproductive senescence in the literature, we see that we poorly understand the effect of environmental variation on variation in reproductive senescence. And this is what I'm interested in today, and I'm testing whether individuals and populations that live in different environmental conditions differ in their reproductive aging. Seabirds are a good study system to study that. For many reasons, I'm working today with black-bird albatrosses. They're long-lived, they have high annual survival, obligate parental care, and importantly, they can display intermittent breeding strategies, which means that every year an individual decides or not to engage in reproduction, which makes it a good study system to study how reproductive performance varies with age. I have access to data from two populations that are characterized by very different environmental conditions. So Kerguelen, which we see in blue on the map, and Bertille in South Georgia on orange. To briefly summarize the variation between the two populations, or between the two places, oceanographic conditions are highly variable and a lot less predictable at Bird Island compared to Kerguelen. And the birds also feed on different trophic levels, feeding on Antarctic krill at Bird Island, which is highly variable between years, and on less temporally variable fish communities at Kerguelen. So in this context, I'm expecting a faster pace of life at Kerguelen, where the environment is more predictable. I expect it to translate into stronger and earlier senescence. I'm testing whether the response, the reproductive senescence is due to plasticity at the individual level. And also, we predict a higher sensitivity to environmental variation at Bird Island. So I'm using long-term individual-based monitoring of reproduction in black-bird albatrosses with close to 1,000 individuals in each population. To briefly summarize the monitoring, we know parent identity, we know their age, the breeding success is monitored, so you know if the bird lay an egg or not, and every year it can produce up to 1 offspring, and we use fledging success as our measurement of reproductive success. And our analysis is divided in different questions. I'm testing whether populations differ in aging pattern, and at the individual level, whether plasticity or selection shapes this age-specific variation in breeding success, whether individuals differ in their aging responses, and when looking at the environment, I use the Global Climatic Index to test the link between environment and breeding success. So what did we find? So as I said before, I expected a faster pace of life at Kerguelen, where the environment is more predictable. I expected to translate into higher investment in early life, stronger senescence, and shorter lifespan. If you look at the probability of fledging a chick, how it varies with age, so you can see in blue the responses at Kerguelen, in orange at Bird Island, you can see that overall there's a higher fledging success at Kerguelen. There's also stronger senescence rates at the population level, an earlier onset of senescence. The birds start breeding at an earlier age at Kerguelen as well compared to Bird Island, and they have overall a shorter reproductive lifespan. So altogether, this goes with the idea of a faster pace of life in the birds breeding at Kerguelen. And now if we focus on the individual level, I won't detail it too much here, but we showed that the responses, the age-specific variation in breeding success was explained by plastic responses, as well to a certain extent due to selective appearance and disappearance effects. But what's even more interesting is that if we start looking at variation in individual responses, we find a strong variation among individuals in reproductive aging and senescence rates, both within and among populations. There's, interestingly, there's nearly 3 times more variance in the intercepts, meaning in the average performance of an individual at Bird Island compared to Kerguelen. So we think that these may reflect different strategies, both between populations and between individuals from a given population. So if we think about the environment, as I said before, we expect higher sensitivity to environmental conditions at Bird Island. That's what we find. We find that about 30% of population level variance in breeding success is explained by year effect at Bird Island, as opposed to only 7% at Kerguelen. And this is quite easily visible if you look at the average population level fledging success over years. You can see at Bird Island, still in orange, that it highly fluctuates between years and it's quite low, compared to Kerguelen, where it's more stable over time and higher. When looking at a global climatic index, here the Southern Oscillation Index, reflecting La Niña and El Niño oscillations, we found that there was a significant link between SOI during the breeding season and the probability of fledging a chick at Bird Island, but only a trend, not really significant, at Kerguelen, showing that there are stronger effects of these environmental fluctuations at Bird Island. So now, if we summarize these findings, we tested whether individuals and populations that live under fluctuating environmental conditions differed in their reproductive aging under the pace of life hypothesis. As we predicted, we found that individuals from Kerguelen display a faster pace of life characterized by earlier and stronger senescence compared to Bird Island. In both populations, we found among individual differences in aging patterns. We also found that there was more variation in individuals' average breeding success at Bird Island, maybe more differences in average quality or performance. And we found more environmental sensitivity at Bird Island compared to Kerguelen. The next step of this project is now to go further and try to understand what drives these inter-individual differences in aging within the population. We also want to assess the effect of fine-scale environmental fluctuations on breeding success. And I've been here focusing on what happens over an entire lifetime of an individual, but to better understand what's going on, we want to look at a shorter temporal scale, to look at the cost of reproduction and its carryover effects, and to do so because how much you're able to invest in reproduction depends on how much resources you have. We want to go deeper into this resource acquisition allocation trade-off to understand what's going on. And with that, I thank you for listening. I'm happy to answer your question. I thank all the collaborators of this project, field worker, founding bodies, and yeah, there's a little message. If someone has room in the car and go to northern Spain or southwest France, and wants some company, just let me know. I'm looking for a car.
Thank you, Bertille. Questions for Bertille?
Just a clarification. How much of the variation observed was explained by the selective disappearance?
Sorry, can you repeat the question? It's hard to hear.
How much of the variation was explained by the selective disappearance?
I haven't measured it, so that's something I plan to do, to be sure. So I can't give you the answer right now. It was highly plastic, and the response due to selection was less strong than plasticity, at least. But I really want to measure both and be able to compare it between the two populations to see how it differs.
Thank you. It was really cool to be able to see changes in pace of life within the same species between populations. So my question is twofold. Did you investigate overall lifetime fitness between these two populations? And secondly, I was really interested in the contribution of the non-breeding movements on migration and how that influenced the pace of life between those two, because we see that in passerines.
Thank you for the question. So first answer, sorry, I already forgot. Yeah, fitness, sorry. So I wanted to compare it to see whether we have two different strategies that lead to the same fitness, the same number of offspring produced. There's still a slight difference that at Kerguelen they seem to produce a tiny bit more offspring in their life compared to Bird Island. That's what we found. And then the long... no, not really, no. That's not part of my project.
Any more questions? No? Okay, thank you.
Thank you.